welcome everybody. Today we're going to be talking about two different things. We're going to be talking about constant variables, and we're going to be talking about debugging. So then you're going to have a fun little coding competition to try and debug a couple programs. It'll count as an actual programming assignment, but it should just be kind of a fun little way for your professor to troll you. Okay, so let's talk first about const variables and the other about debugging. So const variables, there is this thing called the const keyword. We've talked a little bit about it before, but we're going to talk more about it now. So when you make a variable, if you put the const qualifier in front of it here, what that means is that the variable could be set here when the variable is created, and it cannot be changed at any other point in time. So the reason why we do this is sometimes you just don't want a variable to change, right? Sometimes you actually just say, this has my social security number in it. It should never not have, it should never be something different. Some people, in fact, code in such a way that all variables are immutable by default. In other words, all variables are const by default. That's actually a coding style that's very common these days. If a quantity shouldn't change during the program, make it const. So, for example, if you're making a football game, you're making Madden 2024. If the points per touchdown is fixed at 6, make it a const. Okay, make it a constant integer, points per touchdown 6. And there's two, probably three major reasons why you would want to do this. The first is it makes your code more readable. So rather than your code saying 6 times TDs, TDs being touchdowns, I probably spelled it out as touchdowns. We could say points per touchdown times TDs. That makes your code easier to read, because if there's a 6 just sitting there, you're like, why is it a 6? That thing is called a magic number. Okay. You should basically never have any numerical literals in your code. This thing's a numerical literal. It's just a number just sitting in your code. The only ones that are, are 0 and 1, right? So if you say integer x equals 0, that's fine. We all understand you're initializing to 0. You don't need to explain that. Likewise, if you're doing a product and the product is going to start at 1, that's fine too. Nobody needs an explanation for that. But for anything if you have a for loop that's saying for int I equals 0, I is less than 12, I plus plus, any experienced computer programmer is going to be like, why is there a 12 there? What does that 12 mean? Is it months in the year? Is it points? Players on the team? What does the 12 mean? You need to explain this to me. And we would typically have a negative reaction to that during a code review. You're like, don't put a 12 there. That's a magic number. Put points per, make it a constant, and if it's if you want to have a for loop that prints the calendar for every month in the year, then make a constant integer called months in the year, usually all caps with underscores between them, which I call screaming case, and set it equal to 12. And you can have a for loop that says for int I equals 0, I is less than months in the year, I plus plus. Now we know that you are looping over all of the months in the year, and it's readable and it's understandable. You don't have a magic number in there that we have to guess. So it makes your code readable. We actually understand. Code reading is actually an important skill, and it's a skill that you're going to get to practice today during the debugging assignment. Because you're going to have to look at my code and try and figure out what the hell I did to it, because it's pretty messed up. Some of it. It's actually hilariously bad. Some of them. So it makes the code readable. Second reason, it makes the code easier to change in the future. 90% of all computer science is not writing a new program from scratch, right? The vast majority of computer science jobs, you go to work for a company and they have a product. You have a Microsoft Word, or you work on some finite element modeling simulator for architecture, or a wind flow simulator for wing simulations. They have a product, and in fact, this product could quite possibly have been around since the 1970s, right? It could have, you can get hired, and the original authors are dead, right? That does happen. You're like, I don't know what any of this means, right? And so it's nice if they use something like this, because now you understand, oh, okay, the 6, instead of a 6, it's points per touchdown. I actually understand what's happening. But the second big thing is that it makes it easier to change. Let's say the NFL changes the rules, right? because they do that occasionally. You know, they added in like 2-point, conversions and things like that. Occasionally they do change the rules, and so you could change it so that instead of points per touchdown being 6, you could change it to be 7 in one place. In one place, which is important. You don't want to repeat yourself. I'll say it again. You don't want to repeat yourself. If you had to change this 6 to a 7 in 50 different locations, every place a touchdown is mentioned, then there's a pretty good chance that you're going to miss some of them, right? When you're trying to update your code, and you got all these things like this, there's 6s everywhere, there's 3s, there's 2s, the number of points of a safety changes from 2 to 3. Is that a safety OC? What does that mean? A conversion? I don't. Is this 6 the same thing as that? Like, what is that? There's a pretty damn good chance that if you have like 50 different 6s through your code, some of them have to do with footballs, some of them don't. Some of them might be like half the months in the year or something, and it could be very difficult to make changes to your program, because if you change some of the point values from 6 to 7, some of them not, then maybe you have the home team getting 7 points a touchdown and the away team getting 6. You can have very serious bugs as the result of not using constants. So the nice thing, the better way of doing it, rather than having all these magic numbers just sitting there, you could have millions of lines of code, and you control F for 6 and you get 500,000 hits. You're like, I don't know which one of those 6s have to do with points on a touchdown and which don't. Instead, all you have to do, if you're consistent about using this, there's just one place. You just change points per touchdown from 6 to points per touchdown per 7. Then every place that uses it automatically updates, and you're good to go. That's proper coding style. Okay. One of the things that I try to teach in this class is like proper coding style. Okay. And part of that actually is comments too. I want to make a note about comments real fast. So if I have some code, I'm going to know what we have in here. It's really helpful. Like, you got all this stuff, you're getting the time, you're doing subtractions. Like, what the heck is this? The one comment I have in here is not very helpful, right? This is how you should not be writing comments. Okay. Now, some people take it too far, right? Like, so some people will, like my TA when I was in college, when I took the equivalent of CSI 40, my TA wanted a comment on every line of code. So I'd have to write things like this: create an integer named max FPS and set it to 10. Like, I know I can read the code. You don't need a comment for that, right? This is a completely redundant comment. It doesn't tell me anything. This is useless. It's a waste of space. It'll distract me away from what's important. Instead, what you should be doing is not like, and this should probably be a constant, right? Instead, cap the frame rate at 10. In other words, explain what is that, like, why, what's actually happening here. What is the purpose of this variable? That's far more useful in a comment. So for example, if I have a big loop, the best comment that I could have over that loop would be like, this loop is finding the maximum value in a vector, right? Great. Just one comment over 5 or 6 lines of code. And once I read that, I'm like, okay, I understand the purpose of this loop. And so now when I read it, I understand what's happening and everything makes sense to me. If you just give me a giant loop like this, and I've never seen, I mean, I wrote this, so I know what it does, but like if I had never seen it before, I'd be going like, okay, we're getting the time, we're taking the delta time, which is the difference from the last frame to the current frame. We're outputting the delta time for some reason. We got a ternary operator in here, and it's doing some math. And then we're setting the last frame time. We're printing hello world for some reason. What's up with that? And then it goes to sleep for some amount of time. So this block of code here has no comments on it, right? This is bad. So what we should do instead is cap the frame rate at max FPS. Okay. And we could, maybe there's a good spot. I don't know. But just explaining the purpose of this code. Like, why are we doing all this stuff? And hello world should have a comment saying, this is a placeholder for actual work being done. Compute how long the last frame took. Like, you explain what's going on, and then everything just sort of makes sense from there. Like, you like, oh, okay. Because remember, code, like, the way that we teach computer science is not reality, okay? It's not reality. Like, I've never worked for a company where it's like 1 week, they're like, okay, you need to translate English into Japanese from a blank file, begin, you've got a week. And then the next week they're like, all right, now we're going to practice for loops, you know, and we're going to, you know, do a times table. Like, that doesn't exist. The reason why we do these assignments with you is to train you in like how a for loop works and how to do a doubly nested for loop and how to write a function. Like, each one of these homework assignments is designed to teach you something, but we might be fooling you that this is what computer science is like as a career. As a career, 90% of the time, you're working on code that already exists. And you have to be able to find bugs in code that already exists. You have to be able to modify code that already exists without breaking it. And a big part of that is called testing. You have to create test cases for your functions. And so that when you change the function, if the tests still pass, great, I didn't break anything. If suddenly the tests start failing, I'm like, oh shoot, I broke something. And then you can undo your change, right? Like, that's what reality is like. It's not just you write the code now and throw it away, right? How many people here have like opened up like calculator from like week 2 or what, you know what I mean? Like, you probably haven't looked at it, you know, since then. You know, but in reality, you're going to be in the same thing over and over again. Now, and another thing related to comments and const variables is you have to take mercy on yourself in the future, right? Because like, I understand what's happening here, you know, and I understand right now why I put hello world there. It's just a placeholder. Like, that's instead of you know, having the whole video game, you know, do simulate physics and raster screen. I'm just printing hello world just to kind of demonstrate how you could cap frame rates. But future me, like, if I came back in a year and looked at that, I'd be like, why am I printing hello world? That is stupid. You know, I don't know what this is doing. Like, I would not remember my intention. And so you have to use comments like this is a placeholder. Now I understand, like, okay. So that'll get pulled out, and then actual code will go in there. Okay. So yeah, leave comments for your future self, you know, and you can also do like a to-do, and then it'll actually highlight in Vim. So like, if you have a bug, like I have a bug here, to-do, replace this with Chrono. So right now I'm using the C-style way of getting the time. I need to update this to use the correct C++ way of doing it. Okay. I just kind of ran out of time yesterday in 50B when I was doing it. So, you know, make notes to yourself. Like, this is not the final product. You know, this is something that is a temporary, you know, stopgap that should be replaced in the future. Because sometimes you don't have time. Sometimes you just want to knock something out, but just leave a note to yourself, because you are not going to remember this. A year from now, you are not going to remember any of that, right? And so you'd look at it and be like, what the hell am I thinking, you know? Why did I not use Chrono? And if you leave a note like that, you're like, oh yeah, I need to do that. And then you just fix it. It's not a big deal. So intention, okay? Comments should express your intentions, the purpose of the code. Don't do things like, this is, you know, I am creating an integer named mix50. No, don't be like what my TA required. Instead, I want you to have comments that kind of express the purpose of a block of code. You know, 5 or 6 lines. Sometimes, you know, you can put a comment on 1 line. That's fine. But, you know, a lot of times I'll just put a comment over a loop and just explain what this loop is doing. And that's good enough, you know. And then when I come back to it a year later, I can be like, oh, okay. All right. I get what's happening here. All right. So that's my little rant on comments. So the third thing that's good about consts is the optimizer can actually make use of it. So the first 2 reasons to use const is, first is, you know, you can prevent yourself from changing the variable accidentally. That's nice. Second is code maintainability and readability. And the third is the optimizer can sometimes make some optimizations that wouldn't be possible if you had a variable. Like if it couldn't be convinced that the variable's not going to change, then it might have to like reload the value from RAM or something like that. Whereas when it's a constant, it just knows the value is always going to be 7. Always. All right. And so the compiler oftentimes will just remove the variable entirely. Like it won't even, like the constant won't even take up RAM, like in a lot of cases, because it doesn't need to. It'll just put a 7 into the code. Like we're going to multiply by 7 and be done with it. Okay. So yeah, this is bad code here. 25 times A plus 10 times B plus 5 times C. Like if I just gave that to you out of context, you'd be like, I don't know. What is that? You know? But if I had quarter value times A plus dime value times B plus nickel value times C, like now you know, like, oh, okay, all right. So A is probably the number of quarters. Like A probably should be named the number of quarters. You know, but notice that even just with the constant having a name there, like you're like, okay, I understand now. Okay. So write code like this. Don't use magic numbers in your code. The only numeric literals that should appear in your code outside of creating a constant would be 0 and 1. Now, there's a couple tricky bits with constants. You cannot pass a constant to a call by reference parameter, and the reason for that is because call by reference parameters allow you to change it, right? And so if you were to pass either a numeric literal like the 5 there, or quarters value, which holds 25, if you were to pass that call by reference, then the call by reference function would be able to change it. And that's not allowed. And so it will give you a compilation error. You cannot pass a constant to a call by reference parameter unless the call by reference parameter is const reference. It's const reference, it's fine, because you can't modify a const reference parameter. But if you just pass it in by reference like this, you can't. It will not compile. It will not allow you to pass a constant. You can pass it by value. That's fine because it just duplicates the thing, and no harm, no foul. But yeah, if you had that add function there, and I didn't even look at the function body. I'm just covering up the function body. If you just showed me that first part there where it says int add parentheses integer ampersand a right side ampersand, then int ampersand left side ampersand b. By the way, the spacing doesn't matter on the ampersands. I did this deliberately to make that point. You could put 5 spaces on both sides if you wanted to just hate people. If you just had that signature there and I block out the function body, my immediate thought as an experienced programmer is that you're modifying A and you're modifying B. That's what you're telling me when you have a call by reference parameter. A is going to change and B is going to change. And so it makes sense, like you can't pass a constant to it because constants can't change by any means. Okay, so either make that call by value, which is what I would do. There's no reason for that to be called by reference. I just change the ampersand A to be A, ampersand B to just be B, just call by value, it's fine. Integers should probably be passed call by value. Strings and bigger objects should be passed by const reference by default. But either making it const reference or making it call by value is the correct fix there. Okay, so const reference is allows you to pass a constant to it. That's fine. I would still probably just do call by value instead, because it's a little bit faster to do call by value on an integer than it is to do call by reference. Although it might get optimized away. Who knows? All right, so now let's talk about debugging. All right, so debugging means taking a program that's buggy, that has bugs in it, that has errors in it, and fixing it. Okay, and you could turn this into an entire career. Okay, there are people whose entire jobs are just debugging other people's code. They don't. I mean, they know how to write code, and obviously, because in order to debug software, you have to understand software. Like that's a given, But they're not going to be writing Microsoft Word from scratch or something like that. Mostly, they're just given a stack of bug reports, and they're given a program, and then they find what line of code in the program is causing this bug, and they fix it. But even if you're not like a full-time debugger, you need to get good at finding bugs. And the reason for that is because if you're writing software and you have a bug in it, you could spend 8 hours tracking down that bug. And those 8 hours that you're tracking down the bug in your own code, because you forgot to initialize a variable or something, is code that you could have been spent writing new code, right? So even if you're a person who writes code and doesn't work full-time as a debugger, you need to get good at debugging. And that's why we're going to be doing the lab assignment today that's worth points. So don't just disconnect and bail out today. It's worth points. You need to get good at debugging. Okay, so there are full-time jobs that do debugging. There's testing positions where you create test cases and create test suites and all this kind of stuff to test software and make sure it's not broken and make sure that any changes don't break it, because if you change something that breaks it, the tests fail now and it'll detect it. There's a lot of automated testing. It's a big world, a lot of positions in it, and they pay reasonably well. Depends on the years of experience, but you're probably going to be making 150, like not a lot, but like a reasonable small amount of money. In the Bay Area, by the way, 150 is not a lot of money. Like you're like 150, I could live like a king in Fresno. You could, but in the Bay Area, 150, you're gonna have a roommate. Like you're gonna be splitting a 2-bedroom apartment with a roommate on 150 a year. It's not nearly enough. A friend of mine bought a condo in Palo Alto at it was like 970, 10 years ago or so, and it's up to 1.7 million now. So the mortgage on it, I looked it up on Zillow in the previous class. The estimated mortgage payments on it would be $13,000 a month. So, and that's for a condo. Like that's not like a 4-bedroom house. It's a 1,600. It's a large apartment. It's a 1,600 square foot condo. It's nice neighborhood. It's Palo Alto. Palo Alto's pleasant. But that's $13,000 a month in rent. So for a 3-bedroom, so you can have 2 roommates. $13,000 a month times 12 is $156,000 a year in mortgage. So yeah, you're like, oh, I'm making $150 a year. Look at how rich I am. No, you can't even afford your own condo. In Palo Alto at least. There's less expensive areas to live. But even if you get 2 roommates, that's still $52,000 a year in just paying for rent. And if you're making $150 a year, the Uncle Sam's probably going to bite off a quarter of that. So you're probably walking home with, I don't know, 100-ish. And about half that's just going for rent, So congratulations, you get to live on $4,000 a month, If you got roommates, you're not going to starve. You'll be fine. But it's not the life of luxury that you think it is. If you want to live the life of luxury, what you do is you get a remote position. 6 digits isn't always enough. No, that's like mid hundreds, and that's not nearly enough. Like my buddy and his wife, they lived in a 2-bedroom apartment. Both of them making, I don't know, 200, 300 a year. They lived in an apartment for about a decade to save up enough money for that down payment, on a condo. It's a nice condo. But the pro gamer move, I think, is to get a job at Bay Area salary while working in Fresno and paying Fresno rent instead, which is still high, but not $13,000 a month. Okay. So so lots of jobs in it though. It's a big field. All right. So the three main kinds of bugs are compile time bugs that you will encounter when the compiler tries compiling your code and it says, no, you did something wrong. That's a compile time bug. Category 2 is what's called a runtime bug. A runtime bug means you don't discover it's wrong until you run it, and then it's going to an infinite loop, or it's just not printing anything. Prior to the 12 o'clock class, the student came in, and her code wasn't printing anything at all. And so I looked at it, I'm like, all right, we'll put a cout statement in there, and let's see what's happening. And It turns out there were two bugs. First, she didn't have a break. So like, you're doing CNs, got to check to make sure if there's an error. She wasn't, so there was one problem with that. And then the other problem was that she didn't capitalize it. She didn't capitalize an A, right? And so she was doing a string compare. If the string compare matched, print, otherwise do nothing. And so her code was doing nothing. And the reason for that was because her code had a lowercase a and the file had an uppercase A, so it didn't match and it wasn't printing anything. So she kept running and just nothing's happening. And if you don't know how to debug that, then you'll just sit there and stare at it and be like, I don't know. I don't know what's happening. You stare at your code, it's not very helpful. And so you need to develop a habit. You need to develop skills of debugging these sorts of things. And that's kind of what our lecture's on today. That's what our lab time is going to be on today. Next to the junkies. Yeah. Like, another one of my friends lives in Little Italy, and homeless people keep just sleeping on her door, like across her door, and like she calls the police, and the police don't do anything. And so she kind of gets stuck inside of her apartment sometimes. Yeah, it's that's the Bay Area. It's good times. You pay through the nose for a city that kind of looks like it's falling apart. The third kind of bug is called a Byzantine error, and a Byzantine error is fun. You set a variable equal to 3, and then later on you print the variable and it's 7, and you haven't changed it anywhere in your code in between, and you're like, "Whoa, what's happening here?" I didn't change it, and the value changed. What's going on? Those are fun. Those are great. Those are great bugs. Okay, so let's first of all talk about compiler bugs. These, for an experienced programmer, like, these are not serious. For a new programmer, when you don't know how to write a for loop, sure, your code's not going to compile, you're going to get stuck. And you can just post your code onto the help center and be like, hey, why is my for loop not working? And people would be like, you used a semicolon or used a hyphen instead of a semicolon or something. The important thing to know here is when you compile your code and it doesn't compile, then you will get an error message that looks like this, where it says test4.cc :13:1. What that means is that in the file test4.cc, line 13, character 1, that's where your error is. But is it there exactly? Maybe. Maybe not. Because if you have something like here where you have a missing semicolon error, oftentimes the problem is actually on the line before it, because the compiler doesn't know that you need a semicolon until you need a semicolon. So if you forget a semicolon, then it'll just go on to the next line. It's not a problem. Because in C++, right, you can always do something like this, like that's fine. That's perfectly acceptable code. It's ugly. But C++ doesn't know that you need a semicolon until you get to the next line. And then it says, we expected a semicolon there. So it's very common for you to have to look up one line. So if you miss a semicolon, you're going to get an error on the next line. Okay. Another trick here is g++.cc. So it's saying in the file main.cc, line 18, character 17. So you can vim main.cc plus 18. So that is the line number. So anytime you get an error message, if you want to jump to that line immediately in vim, just say plus 18, and then it will take you right to the line where the error occurred. But again, it could always be the line above it, right? So that's our missing semicolon. So whenever you get a compile bug, learning how to decipher this little cryptic looking string that you get here is extremely useful. The file, the line number, the character. Character usually doesn't matter that much. But maybe it does. I don't know. All right. All right. If you get a ton of error messages, then you can pipe the result using vertical / less. And what that will do is, let me see if we can break this code, then main.cc. See if I can break this. There we go. So you can get tons and tons of error messages. It's still just on one page, but whatever. Let's see if I can make more error messages. There we go. Okay. So how many error messages did I get, you ask? I got 14 lines. Is that it? Disappointing. Anyhow, so if I pipe the results of this vertical slash ampersand through less, then what I get is one page of errors at a time. Oh, vector's not declared. Well, that's not very interesting. Let's put that in there. Let's see if that will give us 106 lines of code. 106 lines of error messages. Great. Okay, cool. So here we go. So this is one page, second page, third page, fourth page, fifth page of error messages, right? So that is super helpful, C++. Never change. So C++ is like, in my book of grudges, that's probably the #1 grudge that I have against C++ is just the error messages. Like, this is a simple mistake, right? Like, instead of saying for every integer x in vec, I said for every integer in x.begin, right? Very simple mistake, very simple fix. But the compiler just like went ape, right? And there's really no way of turning off all those extra error messages. I've done the best I can. I have compile flags that sort of limit the number of errors you'll encounter. You can see that even still, you'd still get just tons and tons of useless error messages. So that's definitely an area where C++ needs to get better. It has been getting better, but it still needs to get better at it. So when you get a ton of error messages like that, which will happen to you in C++, pipe the results of it, and the ampersand there means a standard error, which is where the errors appear, through less, and you'll get one page of errors at a time. And usually you want to look at the very top error. The very top error is usually the most useful one. Like, you forgot to declare a variable, and then all the errors below it are like, I don't know what this x thing is you're adding 2 to. I don't know what this x thing is you're trying to divide 2 to. You know, like the very top one, like you forgot to declare a variable, is usually the most useful one. So when you're fixing compile bugs, fix the #1 compile bug first, you know, and then work your way down from there. Always start at the top and work your way down. Okay, next. Let's see if you guys can figure out why this code is not working correctly. So we're setting x equal to 7, and so we would expect that the code down here would print goodbye world, right? Because x is 7, and our code says if x equals 1, print hello world, otherwise print goodbye world. But our code is not. We get a runtime error. We run this, and we're expecting to see a goodbye world, and we get hello world instead. So does anyone see why this code is always giving us the opposite answer from what we expect? Is it the compiler's fault? Is the CPU misfiring every time? You guys remember? Yeah, good. So remember what I told you guys before. 1 equals is assignment. 2 equals is comparison. Okay? So this is not comparing x to 1. This is setting x to 1. And when you do an assignment, as a fun side fact, it also returns the value that was assigned. So is 1 true or false? Is the number 1 true, or is the number 1 false? What do you guys think? What do you know? What do you remember? It is true. And so every time you run this code, it will print out hello world instead. And as a side effect, your x is now 1. You thought x was 7. It's not. It's now 1. Congratulations. So also, this code won't compile at all. Does anyone know why this code will not compile? There are 4 bugs on this slide. Curly bracket. No. That's actually a very common mistake that students make on the competency exams. You do not need a curly bracket if you have 1 line of code. Okay? So an if statement can either be followed by a single statement like this, or it can be followed by a curly brace with multiple statements inside of it. Or 0 if you want. 0 or more. So You do not need curly braces like this. A lot of professors will teach that you have to have curly braces. I personally don't care one way or the other on it. It helps fit on the slide better if I don't. If I tried putting an extra 4 lines of vertical space up there, it might shrink the font. So we're missing curly brackets. No, there. It's fine without it. It's fine without it. We have 4 error messages. We have 4 errors. We have 4 syntax errors on the screen here. Anyone? This may or may not come up in about 10 minutes. Inside of midterm 40A, your first lab time assignment for today, it's got this bug on there. It's got what are called smart quotes. So, thank you, PowerPoint. Very cool. The issue, if you were to copy and paste this code, is a smart quote. Smart quote is one that curves inwards. What you actually want is a vertical quote. A vertical quote is valid C++. A smart quote is not. The compiler will reject smart quotes. So if you try copying and pasting code from PowerPoint, I do fix them from time to time, but I also leave some in as a warning to others. So if you were to copy and paste that code, it wouldn't. Now I fixed it for Hello World. Goodbye World still has the smart quotes. That code would not compile. C++ would complain about the quotes. It's like I don't know what to make of this, And maybe that's something that could be fixed. I don't know, but yeah, if you just copy out of PowerPoint, a lot of times the smart quotes are actually going to get you. Okay, so so anytime you have a logic error like that, the first approach I always take is just see out all the things. Okay, that's you'll hear me say this a lot. Like you got a loop and it's running and you're not quite getting the right answers out of it. Just put a cout statement in and just be like, here's variable X, here's variable Y, here's variable Z, and just every time the loop iterates, just keep an eye on it. Create a test case that's fairly small, big enough that it'll exercise the code, but small enough you can actually mentally solve the thing in your head, and then you look at the numbers coming out and see if they match. Okay, this skill right here of being able to figure out what's wrong with a runtime bug is what separates out students that fail out of computer science and students that pass. You have to develop this skill because you're writing code, your code doesn't work right, you get stuck, you stare at it, you don't know what the problem is. You're dead, right? Like there's nothing you can do at that point, right? Like if you didn't know that the problem here is with the single equal sign, you're just dead. Like you're like, I don't know what to fix. I don't know what's going on here. It's just not working right. So you have to develop a strategy for figuring out what's happening. And one of the best approaches is doing something like this. Like you've got this code, and then I just like it wasn't working the way that was in my head. And so what I did was I just put in a cout statement after every line. What's the value of X and Y? 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 And then I could go, when I run it, I look at the value step by step, and I'm like, oh, that's different from what was in my head. Okay? So let's do it together. Let's see if you guys can figure out what's going on here. So we've got integer x is 0, y is 2. We say x is equal to 2 times x plus 2 times y. What is the value of x after that first statement there? After we say x is equal to 2 times x plus 2 times y, x is 0, y is 2. What is the value of x going to be after that line? 4 is correct. Okay. And what is the value of y going to be? Did y change? No. So y is still going to be 2. Okay. Now the next line. We've got x is equal to 2 times x plus times 2 times y. So y is still 2, x is 4. So what is the value of x going to be after we say 2 times x plus times 2 plus y? And if you say this won't compile, you're wrong. This is actually valid C++. We got a 4, we got a 32, maybe a 5. I'll take a vote for 5, 8. Undefined behavior, maybe. Okay. Moving on. I think the actual answer is 32 if I'm remembering properly. And then we have this line right here, which is one of the reasons why I got hired actually to teach here full time at Columbus Community College. We were given our choice of 5 topics when we were applying to be a computer science professor, and a lot of them were fairly, complicated topics like pointers and memory management and C++ and things like that. But one of them caught my eye, and that was the increment and decrement operator, postfix and prefix. And literally just adding and subtracting 1 to a variable. And I'm like, how the hell could I make a 15-minute long video, lecture? It wasn't a video. How could I lecture for 15 minutes on plus plus, right? Incrementing a variable by 1. And I thought about it, and I'm like, okay, there's some really gnarly things you can do about it. And a lot of it's undefined behavior, mind you. But I just love x plus 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 y being valid C++. There's just something about that that's just chef's kiss amazing that the language would accept that as a valid, bit of code. And by the time I finished, I started the lecture. I'm like, hey, today I'm going to teach you guys how to add 1 to a number, and they're like, what? I got 15 minutes. We got to go now. It's going to be a wild ride. By the end of it, I had them, understanding what x plus 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 y meant. And even like the biology people and the counselors were like, okay, the answer is going to be 32 or, whatever, and they solved it. So this is literally, got a bit of nostalgia for me because it's why I got hired here full time. So let's say x was 32, x plus 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 y. What's the value of x going to be? What's the value of y going to be? X is 32, y is 2. I don't think that statement is valid to do. It's valid C++. It's undefined behavior, I think, but it's valid. This will compile. All right, the answer is 35 for both, which is 32, and we pre-increment y to be 3. 3 plus 32 is 35. The plus plus here and the plus plus here actually end up doing nothing because it increments them after the expression's evaluated. The value then gets overridden by being placed into x here. It is, I believe, a code point violation, so I think it's actually undefined behavior. But the point is that if this code isn't behaving the way that is in your head, see out all the things. Do you guys see this? Like literally every line of code. Paste. What's the value of x and y? What's the value of x and y? What's the value of x and y? And so when you run this, it goes like this. And then you get a look at it and go, oh, that's what it's doing. I see. Right? And then you can either yell at the C++ language for allowing this monstrosity to exist, or you could modify the code so it's not undefined behavior, or you could just laugh about it or cry, one or the other. Okay, Byzantine errors. So Byzantine errors, cry, or offer somebody a job. That's apparently another option right there. Just be like, how would you like to work here full time? Clearly, somebody who would do that is a great match for the Clovis Community College spirit. Okay, so Byzantine errors. So Byzantine errors are almost all caused by either memory access problems or like multi-threading issues, or like multiple threads are reading and writing to the same data at the same time. We're not going to handle multi-threading in this class, so the only source of Byzantine errors in this class would be memory safety issues. So if you have an array of size, I can even show you. Let's see. And your array. It's got 10 elements. Let's do this. X is equal to 10. The array is all initialized to 0, and then y is equal to 20. if we set array 10 equal to 42, notice the warning on it. No, you're out of bounds. Okay. It's valid C++. This will compile. This will run. Okay. Cout X, cout Y. Neither of them changed. Okay. Good of them. Because depending on how these things are laid out in memory, we could do this for n I equals 0, I is less than 30, I plus plus, array square bracket I is equal to negative 10. Array is set but not used. Yep. Stack smashed attack. Terminated. Turn off the safety. No. Yeah. The system's protecting me from modifying the other values. But the point is, if you go out of... I wonder if we do negative values. I wonder if that'll actually work. Yeah. Somewhere, like, it's undefined behavior, like where, when you're going out of bounds like this, right? But when you go outside the boundary of an array, C++ will very happily read and write to RAM that is not part of the array, right? So when you say array square bracket I, it will very happily just jump to whatever spot in memory you tell it to. Go to spot 20, go to spot 30, and write there. And if that value had X or Y in it, then you've just changed X without X ever changing. You know what I mean? Like, imagine if the code was just like this, right? Like, imagine we just have X is equal to 10, Y is equal to 20, and then we just print X and Y. Just imagine we have this and it doesn't print 10 and 20. And you're like, what? Why not? I didn't change it anywhere. This should not be possible. That's a Byzantine error, okay? So Byzantine error is almost always caused by arrays. And going out of bounds in arrays or pointers, which are kind of the same thing as an array. We haven't learned pointers yet. Basically the same thing. So the code here is concatenating two different strings together, right? So this is a C-style string, sort of, should be constant, called hello. It's basically an array of characters holding hello world. We've got goodbye that contains the array goodbye world, and we're concatenating the two together. We're going to append the two strings together, and my frame rate, look at that frame rate, it's low. And then we output hello and goodbye. What we get is hello world, goodbye world, segfault. And the reason for this is because this is an array of fixed size, and you're adding things to the end beyond the end of the array, and you're just writing over whatever's in RAM there. And who knows what'll happen, okay? And like some of the worst bugs that I've ever encountered in my history are Byzantine errors caused by either uninitialized variables, which is one of the reasons why I harp on this with you guys. Always initialize your variables. Or you have an array and you go outside the bounds of it, which is also why I harp on you guys not to use arrays at all. I want you guys using what instead? What do we use instead of an array in this class? Vector. Very good. Okay. And if we want to set something outside of the boundary, vector.at10. If we try going outside the boundary of the vector, it throws an exception and kills it. We always use, in this class, .at instead of square bracket. Okay? We don't use square bracket arrays, and we don't use square brackets. Because vectors, technically, you could do that. And now it's just printing whatever's in RAM there. At least we're just printing it, we're not setting it, right? Yeah, we could even set it if we wanted. Corrupted. Okay. So this is why we don't use square brackets. Always use .at. Okay. The only benefit of square bracket is that it's faster, but at your level, you do not want fast. You want safe. You want the code to detect that you went out of boundaries and kill your program. Okay. And Byzantine errors are almost all caused from going outside the boundary and writing to variables that aren't being written to. And then you're like, why did this change? And you have no idea. So fortunately, there's lots of tools these days to help detect it. Like you noticed that that we got an error here. We got well, if we use .at, stack smashing detected. You guys have what's called address sanitizer turned on. So with address sanitizer, if you ever go outside of boundaries, it detects it and kills your program and tells you on this line of code, you screwed up. You done goofed area on, right? Don't do that. And so we've got UB sanitizer turned on for you guys. We've got address sanitizer turned on for you guys. We have the safe standard library turned on. Like we have a lot of safety features turned on for you guys so that if you ever go out of bounds, it will detect it immediately, kill your program, and tell you you went out of bounds, which is how it should be. Like the only time you need speed is like in release, like when you're done. You know, when you're developing, you should always have all the safety features on, unless you just want to see if release mode has broken something, which it does something. Okay. Yeah, if you string cat multiple times, you're just overriding more and more RAM, and who knows what the hell is happening. Okay. Byzantine errors are not fun. You know, you can go through every line of code looking for it, get a friend to look it over, put couts everywhere. You can use a debugger, which we'll talk about on Friday, maybe. No, actually on Friday, I'm giving a talk. So class on Friday is literally, you guys get to attend a conference with me on ChatGPT, which should be fun. We'll talk about debuggers on Monday then, and how you can use these tools to help you track down your bugs. Also, address sanitizer, UV sanitizer, the safe standard library. All of these things are things that make your life easier. There's a lot of tools these days that make C++ actually not bad. If you check, you know, if you check with old programmers, like they'll tell you don't use C++, it's terrible. But they're living in the past. Like they really are. Like anyone who says, oh, you know, it's impossible to like write C++ safely is just somebody who just, you know, probably learned C++ in the 1980s or 90s, and just haven't updated since then. Like you, with all those tools I showed you, like these three things alone is enough to make C++ basically as safe as Java. I've literally never encountered a memory problem that these tools haven't been able to fix. Like it's just that it's that good. You know, you could probably contrive an example that would fool it, but honestly, like these tools are really good, and I have them turned on for you by default, and so you get all the benefits of C++ without the downsides of Java. So it's as safe as Java, or 99% as safe as Java. So you'll always hear people talk about how unsafe C++ is, but you can make it safe if you want. Do we have 2 writing assignments due on Friday? Like what Canvas is? What are the 2 writing assignments? You've got what's it called? You got your data science that's due on Friday. And then the other thing is, well, it's technically due on Friday, but you're going to do it in class right now. So it is a debugging assignment. So let's open it up. So if we go into midterm 40A, there are 3 midterm assignments. They're called midterm assignments because this is what I used to do with my students before I switched away from midterms. There's midterm 40A, 40B, 40C. Each one of them has compile time errors and runtime errors. The compile time errors you'll know that you got when it compiles. The runtime errors you'll know that you have finished. Well, there's no auto grade. There's no input tester. You have to test it yourself. So you're gonna have to read the README file and look at the sample. Type in 1 and 10 and see if when you run it, see if you get a times table that looks like it, because it won't. So there's like a few test cases in here, and when your code matches the output in the README file, you're good. Then move on to midterm 4DB. Okay, so you guys have it a little bit easier this year because you have a language server that will tell you which lines have errors on them. And in fact, there's so many errors, it actually stops. So you have 20 errors, which is the max it'll handle. So I actually put so many bugs into this file. I was actually laughing at the beginning of the 12 o'clock session because I redo this every year. And there are so many errors in this code that it actually stops. It's just like, there's too many, I can't handle this. And it just quits. So you can see, like, this is the last line, here, when it's just like, no more. I don't want to play anymore right here. So there's actually lines, all of these lines down here have bugs in them as well. But the language server is just not, it's just giving up at that point. So, do not share on chat what the bug is. Pray to whatever deity you like. I will give you a hint. Look at the quote there. I told you, a hint earlier in the lecture why the quotes here are not compiling correctly. So there may be something, there may be some hint in the earlier part of the lecture that will tell you what you need to fix to get this working. Okay, so the 40A, 40B, 40C, they each have some sort of like horrible. They have some sort of horrible bug that your TA and your professor were absolutely laughing about when putting them in the earlier class today. So all of them are bad. Let me just show you midterm 40B for the people watching on the interwebs. There's a lot of bugs in this one too. There's a very subtle bug somewhere within here. And yeah, so that's that one. Doesn't find cout. That's weird. Didn't we include IOStream? What's going on with this? You are doing all three of them, and you have 1 hour from the moment I stop talking to do all three. If you do all three by an hour from when I stop talking, you will get 12 out of 10. This counts as a homework assignment. If you don't get it done, well, you're still going to have to do it by Friday. Okay? I will run the auto grader. There is no input tester. You have to test it yourself. That's part of the assignment. You have to learn how to debug. You have to learn how to read code. You have to learn how to, figure out what's wrong and see out all the things and test it yourself. Okay? Oh, this one. I love this one. I don't know if you guys can figure out what's wrong with that one, but it's funny. Lots and lots and lots of bugs on each one. So there's not only a compiler bug, lots of compiler bugs, but there's also a runtime bug. So after you run it, it won't run correctly. And so in order to tell if it's running correctly again, you have to read the README file and type in this. Basically, this is just detecting different chords, right? So the user types in 3 different notes, and it's going to categorize the notes into which chord it is. And you just look at the README file, run the sample input in, see if the output matches. If it is, you're good to go. but it won't be by default. There is a runtime bug in all three of them that you need to fix. There's one, maybe two runtime bugs in each of the three folders. Okay. Can we do essentially anything that makes the program work? Like, are you asking like, oh, could I rewrite the whole thing? I don't want you rewriting the whole thing. I want you like finding the bugs. You know, like the whole point of this exercise is to like look at the code. There is just usually a very small change in there that you need to make, like an off by one error or something. And that's the point of this exercise. The point of the exercise is you look at somebody else's code, which people hate, right? And try and figure out what's wrong with it. Now, sometimes they'll tell you, like, this code is correct, right? So you don't have to, like, I don't expect you guys to be able to debug that, right? So I'll just tell you sometimes, like, this is fine, you know. There's no runtime error in it. It's clearly a compile error, but the code itself is correct. And so, yeah, get practice at reading other people's code, understanding it, and fixing bugs in it. That's just an absolutely essential skill for every computer science major. Okay, so the time is 3:32. You guys have 1 hour from now. I will run the auto grader at 4:32. And may the odds always be in your favor. Begin now. Begin now. Let the games begin now.